Hello, I am Andreas Zeller. I'm the author of the Debugging book, and I'm here to present you a new chapter. So here again is the function that we have been looking at. This is this remove HTML markup function, which is the function that we're going to use for quite some number of experiments. By the way, even the way it works right here is not perfect yet. There are still ways to improve that, and actually parsing HTML code and parsing HTML markup, or generally XML markup, is actually quite a difficult task. So even the version that we have over here that rudimentarily handles quotes and tag delimiters is not perfect yet. You can still improve over that, in particular as it comes to escaping individual characters, or as you come up with individual extra characters, Unicode characters. All of this can dramatically spoil things as it comes to trying out what happens in here. So in this chapter, we're going to introduce so-called tracing. Tracing meaning that you are able to actually look at what the program is doing while it executes. So we're tracing the program execution. And I have to say this, if Python was the worst language in the world, which I think some people actually may agree with, even if Python were the worst language in the world, I would still be super happy to use it, if only for its tracing capabilities. Tracing means that you actually can go and take an arbitrary Python code and examine what happens while it executes. And for this, there's a single mechanism which we call a tracer function. And this tracer function can be invoked right within your program, or more typically a debugger. And this allows you to actually track precisely what's going on. Let me show you how this works. So I'm going to set up a traced version of our HTML markup function. I could also enable tracing right away here in the Jupyter Notebook, but this would actually get the entire Jupyter Notebook to be traced, and that's not something you want to see. You're going to get plenty of events that you're not interested in. And the interesting thing is you have a function that is called syssetTrace. You have to do import sys. You have to do import sys beforehand, and this is the global debug tracing function, which will be called on each function call, actually on every line of the program. And with this, you can define a function to be called, say, traceit. We're going to come to traceit in a second. And then after you set up this traceit function, then you can go and invoke whatever you like. So you can run arbitrary Python code like this. Here we go. So we'll store the return value just to be sure. And when you're done with tracing, don't forget this. This is important. You have to turn it off again. So, and you can do this by passing none to it. And we complete the whole thing by returning red here. Okay, so that's very simple. So and the idea is now that this tracing function, traceit here, trace, oops, where are we? Trace it. No, doesn't work properly. Oh, here we go, finally. Oops. This traceit function, yes, thank you very much, will now be invoked automatically for each and every call in the program. And actually, you can also set this up to be called for each and every line in the program. What does such a traceit function look like? Well, let us define it. A tracing function takes three arguments, and the first one is a frame. A frame is a data structure that contains the current variables of your program. as well as information about the current code that is being executed. The second argument to trace it is an event. This is something that tells you, this is a string that tells you what is currently happening in your program. This can be call, that is a function is called. This can be line, a new line is executed, or return, that is the current function returns. And finally, you also have an extra argument called arg. This is being used for additional information, notably if the function returns, then arg contains the argument. So what can we do with this? Well, very simple. We can say, okay, let's just print things out. Oh, the helpful print. Thank you so much, now that we know that. So we can, for instance, print out the current event that's happening. And now in these, this frame object, we can actually access a number of interesting parts. Notably, we can access the current line number that is being executed. And that's all we do at this point. At the end, you can either return none, and then the traceIt function will only be called with the next function call, or you can also have the whole thing return itself. And then if you return the tracing function itself, or actually any tracing function, then this function will be called for the next line too. So with these two functions, and now with these two functions actually, you can now go and build a full-fledged debugger. Well, a debugger in the sense that you can see what's happening in your program. So if I now go and invoke this remove HTML markup traced XYZ, I will get a number of events. Let's see whether this works. No, it doesn't. You have to import this first. Import this, then define traceIt, then remove HTML markup. Yes, and we get quite a number of, well, we get all these. Oh, now, what is this, all this stuff? Sysset trace, call 2007, 2020. This shouldn't work. So something weird in here because, okay, let's start this whole thing from the beginning. That is going to make life a bit easier, such that we do have, oh no, oops, so sorry. I think we still have the traceIt function running for some reason. So I'm going to stop the whole thing and restart it right here to see what's going on. See, we are, now this is much better already. Yeah, there has been some other definition that messed up with ours. So what we have in the beginning here is we see we have an event called call. This is the call of remove HTML markup, and this happens in line 152. What is line 152? Here's line 152. This is where we are right now. And now we can see how the program actually progresses through the individual lines, 153, 54, 55, 57, and so on, until it ends up in line 167. And then we make a jump back to 157, and 67, which is down here, and 57 actually mark the boundaries of the loop we are proceeding through. So this is not yet super, this is very raw still. So we cannot immediately see what is going on in our program right now. We still have to find out what these lines are, and we have to look these up in our source code. Fortunately, there's way more things to be done. By the way, since we have a question here, this return traceIt actually means that the traceIt function is supposed to be called for the next line just as well. The alternative is to return none, and then it will not be called until the next function is being called. So you have even more things to look at. For instance, what you also can do is you can look at the current code. And the current code is a code object, which is some binary blob, which is not going to be that super interesting. But what you can do is you can look up the current name of the function that is being called. And if we add this to our traceIt function, and now again execute it, okay, so we still need to define these things. Here we go. Okay, if we now again execute it, then we will see, oh, we actually see the name of the current function that is being executed. And even better than that, We can even, in the current frame, look at all the local variables. This is a dictionary called a frame f.locals. And again, we can look this up. And now you will actually see that not only do we see the current name of the function, but we also see all the local variables, starting with s, which is the argument to remove HTML markup, which has the value xyz. Then we get a variable named tag, which is false. We get a variable named quote, which is also false. And these are actually the variables as they're being set up here. Tag equals false, quote equals false, and so on. And now we can go and actually even find out when does the value of tag change? Does it ever change actually? Well, tag is false, tag is false, tag is false. No, tag never changes. Quote never changes, but out changes because we're processing one character at a time and we're accumulating these in the variable out. So out in the beginning is empty, then it has the string x, then we add y to it, and finally it has the full string x, y, z, which we also return at the very end. And this is still very basic, as you can see, but we can make things even better than that. So one interesting thing is that these local variables here is actually something that you can look up yourself. So you can actually access all these variables as if they were Python, because they actually come as a Python object that's created specifically for you, which means, for instance, you can go and if you want to track only one variable, let's make that frame f of locals of s, and then the whole thing is going to print out, well, only the value of the s variable. Okay, so that's actually pretty convenient. In some variants of Python, I'm not sure whether this works here, you can even assign new values to individual variables. So you can even say, I can even set the value of s to, well, whatever, qux, for instance. Not sure whether this has any effect in here. Let's see. Yes, it works. So, oh, wow, that's cool, actually. This is the first time this worked. I'm super impressed. So here in the tracer function, what we actually do is not only do we access individual variables, hey, we can also change their values on the fly while we're doing this. So initially, s had the value of x, y, z, and after it's being executed, it has the value of qx, and then the whole thing executes with qx till the very end. Assignment of variables, however, is not always possible in all Python variants, so don't rely on it. So this is very basic. This is very basic stuff. And of course, I can now add additional parts to my tracing function. For instance, I can say if frame, so let's see, if we do have a variable named quote in frame f locals and frame dot f underscore locals quote as a value of true. Ooh. Yeah, sort of. Does that work? No, actually, that's not how we do it because it actually is the quote variable. So we can do it this way. And then you can say something like quote is set. Haha, how cool is that? Okay, good. Let's see whether this works. Okay, do we have that at any point? Quote is set? No, because quote never becomes true. But if we do have something like, which version is that? Is that the buggy version or the working version? It's the working version. So let's make this a href to foo.com, whatever, xyz, and we end this whole thing as a link. There we go. So now, as we process through this more complex HTML input, at some point, the quote variable should become true. So we first see the tag becomes true. That's already interesting because tag happens to be set over here. And now all we have to do is to wait until this actually happens. So we proceed, we proceed, we proceed, we proceed. And now we have this extra situation that quote has just been set. And now you can, of course, also remove the remaining logging up here. And then you can simply, then you can simply say quote is set. And you can also say, you can also move it this way, quote is set. And if otherwise, you can also say quote is not set. And since we're at this, you can also still inline frame f line no. That's fun. Is no longer set. Inline, and again we have frame f line number. So, and what do we get this way? Well, what we get is quote is not set in line 155, and it's set in line 157, and in line 157 it is no longer set, and later it, so we can actually track through the entire execution and then find out the path of the execution where the variable quote is being set. So this is this gives you an enormous amount of flexibility during tracing, because this allows you to actually locate precise events. When do things happen? What you also can do, of course, you can also say while. You can also take this big print thingy here and then track all variables at once while quote is being set. So this looks like this. And then you will get an information while quote is being set, you're going to get a trace, and while quote is not being set, you do not get a trace. So this allows you large flexibility as it comes to logging, because you can always set up this tracing function as you like. So this allows you, so this tracing function allows you to access the current variables, the current line number, the current function. But for a true debugger, you also want to be able to actually access the current source code. And how do you do that? Well, again, it couldn't be simpler. There is a module in Python which is called inspect, import inspect. Here we go. And this inspect module actually allows you to get the source code of arbitrary objects. In particular, you can look up the source code of individual functions. So let me just see whether I can get this to run. So here we go. Let's see. So there's a function called inspect.getSourceLines, into which you can pass a function or actually also a code object, if I recall it right. And this returns two values, namely the content and the start line number of a particular object. So let's stick with remove HTML markup for a moment, and then we can see what happens. And now you can go and, and with that, you can now go and print out the current line number that is being executed. Let me see whether I can get this to run. So what is this? So let me just check whether I'm able to do that. How do you do that? Yeah, I have it. Okay, good. So let's not get to the source lines, but does that work? Actually, this should be it already. So we can actually fetch the current line as being the line of the content that is in the current line number. Here we go. But since line numbers start with 1, but arrays start with 0, I think we have to remove, have to have an offset of -1 here. And now this actually allows you to print out the, well, let's simply say the line number and the current line in of the source code. Here we go. So let's keep fingers crossed and see whether this works. No, it doesn't. List index out of range. Why is that the case? List index out of range. No, sorry, I'm confused here. Yeah, I have it. We have to, the content is of course the first line of the source code, but we have to also take into account the starting line number, which in this our case here is 152. Fortunately, the starting line number is also being returned. So we subtract the current starting line number. And do we still have to do -1? That's a good question. If it starts at 152 and if we get 152, then it actually should be the current line. So here we go. And let's see. Yes. How cool is that? Now we can, oh, that's not entirely perfect because there's still a, oh no, what we need to do here is we need to remove this extra line at the end. And now, and now you can actually trace to the entire program, and for every single line, see the source code that is being executed right here. So first we have remove HTML, tag is false, and so on. And now we actually loop through the program and the individual branches that are being taken one after the other until what happens? I think we're going through each character here. That's actually a very long input. And we also see how the individual variables are being set, or at least the appropriate lines are being executed. In the end, the for loop is done. We return, and we return the return value of XYZ. So things are just fun in here. And I'm going to keep things a bit shorter here, such that we don't have such a super duper long execution run. So ABC, and then it actually fits on one screen. Of course, on top of that, on top of the current line, you can still say show the current variables. So again, this would be frame f locals, if I recall it right. And there you go. And then, oops. And then, yeah, I think we now have a mix here. Ah, yeah, I see where the problem is. Okay, let's do it this way. Okay, now here we go. Now you can see actually each line that has been executed. You see the variables. You see the line that's being executed, the variables that hold. Actually, that's not perfect because the variables should be shown first, because the state we're getting is the state before the current thing is executed. So let's put it up here. Frame f locals, and now we actually, wow, almost perfect, and almost perfect in here. And we do end, still one little, oh, now we have it perfectly. So in the beginning, S is equal to ABC, and we invoke this function. After we have invoked tag equals false, we have a variable named tag, which is false. After we invoke quote equals false, we have a variable that of quote being false, and so on. So you see that there's actually plenty of ways that you can access what's happening in your program. You can access the current current line that is being executed. You can access the source code. Actually, the source code, we're still cheating here a bit, because the source code we're having is still the source code of always remove HTML markup. So I am pretty sure that we can also pass a code object in here, such that this would be frame f code. So let's see whether this works. Yes, this does just the same. And now, even if we jump into other functions, we're also going to get their source lines, assuming that there are source lines, of course. Okay, well, and based on this mechanism, in this chapter, we introduce an entire mechanism that is a tracer class, which actually does these things pretty much automatically using a special format, which is this with statement. With is a construction in Python that allows you to execute a body of code while you're making sure that specific methods are being called at the entry and at the exit of the block. And we use these entry and exit functions to turn on tracing and to turn off tracing. So this actually ensures that tracing is turned off at the very end of our tracing session. And with this tracing class, we can now go and, well, do similar tricks as we did before. That is printing out the current function, printing out current variables, accessing source code, all these things in here, tracing calls and tracing calls and returns, including things. And from there on, we can come up with more sophisticated tracers, such as tracing variable changes, that is tracking whether some variable change in its current value. So this allows us to annotate our output with only the changed variables. This makes it far, far easier to read and to understand. And we can also come up with conditions that should be fulfilled for tracing. This allows us to provide specific conditions of interest that we wanted to trace during our execution. So a particular slice of the execution, say a character holds a particular value, a Boolean variable holds a particular value, and we introduce a conditional tracer which allows us to actually specify such a condition, which will then be evaluated on each and every line of code. And if it's true, then the line will actually be printed out. Okay, this is already pretty much all we're having in here. We also have an event tracer where you can specify specific events happening. And in the end, this is a bit more advanced. In the end, we can I'm also showing how to implement such tracers more efficiently. You can imagine that with some piece of code being executed each and every line, the program execution slows down massively, and that's indeed true. It's several hundred times slower. And so in the end, I'm introducing a mechanism, well, that's actually a bit longer, that now goes and dynamically inserts extra code into the program of choice, such that the tracing code is only executed at these very statements. This is actually similar how a debugger in a conventional programming language, such as C or Java works. They work by injecting code into the machine code or bytecode to be executed. And I show that this is way more efficient, of course, but this is also a bit more limited because such tracing, turning on tracing and turning off tracing is then limited to specific locations in the code. Whereas with a general tracer that is executed with each line of the code, you can check for arbitrary conditions, not only things that happen to take place in the current line. These are all the things in the tracer, in this tracer part. We also do have a nice extra, couple of extra exercises on that. In particular, we do have syntax-based instrumentation, which actually allows you to turn a piece of code into a tree, so-called syntax tree, and then work on the syntax tree rather than on the character-based program code. This is super advanced, and you can have lots and lots of fun with that. And I also very much encourage you to go through that. As usual, I would very much like you to try out this all by yourself and do your own experiments with it, and maybe try this out on your own code. And this is already all we're having for this chapter, and of course for your assignment for the upcoming week. Thank you for your attention. And I was happy to present you this tracer chapter.